70-740, Lesson 1, Introducing Windows Server 2016. So this is our first lesson in our Windows Server exercises, and there's no true objectives as far as what we're going to do now. There will be an associated lab that will accomplish with this exercise. But as far as any certification work, no, there's not really anything in here. But this is how we're going to get familiar with Windows Server and all the different areas in it, because we use Windows every day, right? Or at least the majority of us all use Windows every day, probably Windows 10. But do we really understand what all the different settings are, what the control panel features are, how to use computer management, what Server Manager is? If you use Windows 10, you've never seen Server Manager. You're going to become very familiar with Server Manager in this course. So let's take a look at some of those settings. First and foremost, understand that Windows 10 was released in relationship to Windows Server 2016. Windows 8 was paired with Windows Server 2012. Windows 7 was paired with Windows Server 2008 R2. Coming a little bit further back to the future, Windows 8.1 was paired with Windows Server 2012 R2. So you can see as different server systems are released, corresponding versions of Windows were released. We've been using Windows 10 now for many years. There's Microsoft Server 2016, and we now have Microsoft Server 2019, but it's still Windows 10. That's going to remain the same, at least for now. But understand that our computers that we use for our desktops, they're designed to provide us access to an application, just like this web browser that's on my screen showing us our textbook, or playing a game, or running Adobe Reader or Microsoft Word, or even a platform for me to be able to run Microsoft Hyper-V and do virtualization. It is a desktop platform that allows you to run applications, run programs. Servers, on the other hand, provide services. A server is a computer that's meant to be a dedicated service provider. Our clients, which is our desktop computers, are those devices that request those services. When we organize dedicated servers and clients, this is a network, and we call it a client-server network. Here's an example of one of those networks. And as you can see from the image, this is a map that I drew out many years ago of a network that I designed as part of a final project in a computer science class that I had. There's domain controllers, there's read-only domain controllers, there's internet servers, there's VPN connectivity, there's radius, there's routers, there's file servers, there's DHCPs, there's many different servers, as you can see. A lot of different things, but this is what makes up a network. Now these are all servers. Think about how many desktop computers a network with this many servers could support. That is a client-server network. Understand that a server-based network, it's the best network for sharing resources and data. Why do we build networks? Because we want to be able to have connectivity. And it allows us to have centralized network security for those resources and data. When we log into our classroom computers, we authenticate to a domain. We have a set of credentials that we use for authentication. Authentication validates who you are or whose credentials you have. That authentication is then tied to a set of authorization. What permissions do you have? Where can you go? What can you do? We build this with our Windows Server domains. We have domain services. We have federation services, certificate services, DHCP servers to hand out IP addresses and the settings for our devices to connect. DNS servers to provide us the name resolution. Currently, if you're viewing this from home, you're probably connected through your internet provider, and your internet provider is telling you what DNS server to use. That's a public DNS server. In our networks, in our client server network, we will have our own DNS server. And all the clients, all the desktop computers, all the endpoints, what we call an endpoint, they will connect to our internal DNS server, and it in turn reaches out to the internet for any requests that it doesn't know about. This helps promote that security because each and every one of our computers aren't going out to the internet to check things. Even if they were, if they went to the internet to resolve a website name, that would be fine. They could find google.com and they could find amazon.com or microsoft.com. But how would they know about the computers in our internal network? They would never know how to resolve those names. So that's why we run our own internal DNS servers. We provide file and storage services so that our users can have access to the documents in the storage and the resilient RAID arrays where those file and storage services are provided. We run Hyper-V to create a virtualized infrastructure. Think about 20 years ago. Basically, virtualization didn't exist, or it was in its very infancy. And each and every server had to have its own physical box with a power supply, with an electrical connection, with a hard drive, with its own memory, with its own CPU, and all those cooling fans. They generated a lot of heat. They consume a lot of electric. If we look at this example, I can see at least 6, 8, 10, 12, 14, 16, let's say 20 servers. If that is all contained in one server room, can you imagine the amount of heat generated by those servers? A lot. Now you've got to have climate control. You've got to maintain a certain level of humidity. Remember learning about that in your A+? What about air conditioning? Keeping it cool enough in there. There's a lot of infrastructure that's required to support those 20 servers. That's where virtualization comes in. Instead of 20 servers, maybe we have 5 servers who have 3 times the resiliency and resources. In other words, we've got redundant power supplies and redundant CPUs and multiple switches and switch paths, and instead of having 1 or 2 Ethernet connections, each one of these servers might have 4 or 8 internet connections, Ethernet ports. They're very resilient. They've got high redundancy. Of course, they're going to draw a little bit more power, but 5 servers are still not going to compare to the power requirements and cooling requirements of 20. And then we turn those other 15 servers or 20 servers into virtual machines that are hosted in our virtualized infrastructure. So we save on electric, we save on air conditioning costs, we save on power, we save on hardware. Print and document services. Centralize your print management. The ability to publish a printer in what we call a group policy and have it automatically installed on a user's computer without you ever having to touch that computer. Being able to provide remote access via VPN, web application proxies, and direct access, seamless connections to your network. Remote desktop services, so when a user has an issue, you can provide remote assistance and be able to interact with their desktop. Or through the Use of the remote access in the VPN allow a user remote connections, secure remote connections to their internal desktop. Providing web services, providing Windows deployment services, the ability to push out new operating systems when needed, to re-image current computers while retaining your user's settings. An employee leaves at the end of their day, you're pushing out a new copy of Windows. Let's say, for example, your network runs Windows 10 1903. That was released in the spring of 2019. And you say, we've proven that Windows 10 1909 will work in our organization. We're not ready to do any newer images, but we've got a 1909 image that all of our Windows 10 computers will run, and we know that we've proven, and it will be stable and it won't have any problems. You have the ability through Windows deployment services to re-image every computer in your network, and at the same time capture all the user settings that are on those computers, and after they're re-imaged, reapply all the user settings. Your users arrive at work the next morning, they log into their computer, and nothing has changed. They're back in the same environment that they were when they left the day before, but you have a newly deployed Windows desktop that you have been able to successfully send to each and every one of those endpoints. And then using Windows Server update services so that we control when our computers get updates, when do they get installed, how do we go and we can separate what groups of computers get what updates. For example, we may say that a particular update should be automatically installed right now on our desktop computers. However, we're going to make that same update available to our servers, but only on a schedule that we determine. That's just a sampling of what we can do with Windows Server. So let's take a little bit more of a look. So as we can see, our Windows Server has a graphical front end. As a side note, it doesn't have to. We could run Windows Server Core, and we'll be taking a look at this. We have the ability to manage other servers from a server without ever having to log on to the other server. I will illustrate that. How cool is that? We could have, in fact, I'll illustrate. I have what's called a jump box in my former organization that I was employed at. I still do consulting work for them. I connect to that Windows 8 jump box, and I can manage every single computer in their network without ever having to log on to one of those servers. Don't get me wrong. Sometimes you still need to do that hands-on log on. But through the use of our administrator tools and our server manager, we've got access to most every option without ever having to log into a server. If I want to manage DNS or manage DHCP or manage those file services, I can do so through a console without connecting to the actual server, without logging on to the actual server. We'll look at this. But your start menu looks very similar. This is the start menu on Windows Server. It looks almost identical to your Windows 10. You will find as you go through this, so many of the things that we do in Windows Server you're going to be familiar with because you're familiar with Windows 10. It's not a foreign environment. Don't let it intimidate you. We're going to do many of these exercises over and over and over again. Now, granted, as we go through our lessons, each lesson is something new, something different. But, for example, when we get to work on group policies are how we control the experience and the access that users and computers have on our networks. There'll be 4 different lessons that are only on group policies. So it won't just be one and done. Other technologies may be, but we'll be working in an environment that we're familiar with. And as we can see on the left side, when we click our start menu, we've got the power option. We can go to settings. We can go to File Explorer. This can be collapsed down so it's just a single icon. And we can pin programs. We can pin them to the start menu. We can pin them to the taskbar. As you can see on my desktop, I've got many icons that are pinned. For example, Hyper-V, the snipping tool, Notepad++, Microsoft Outlook, and so on. We can use Windows Server settings to be able to control, to change our experience. It's a modern interface for those common configuration settings that normally would have previously been found in Control Panel. So now many of these settings can still be found in Control Panel. There are additional settings such as touchscreen and tablet and privacy settings that are geared toward phones and tablets, and you won't find these in Control Panel. Think about Control Panel. It's been around for many, many years. As newer operating systems came out, there was a need for a newer interface. That's our settings. We can go to System where we can look at the display settings and our notifications, our app actions. What are the default apps when we open a program? What's the default action and those features? Power options. Devices provide quick access to hardware devices such as printers so we can select which one is our currently selected app. Viewing our network and internet. This used to all be done through Control Panel. Personalization, accounts, time and language, ease of access, privacy, and then finally our update and security where we can find our Windows Update, be able to do backups, and also all of our Windows Defender settings. We can still use Control Panel. Understand that it previously was our primary graphical utility to work with our Windows environment and to be able to manage those hardware devices. It can still be accessed. You can right-click the Start button and choose Control Panel. Well, you know what? If I right-click my Start button, do I see Control Panel? No, it's not there anymore. That has been changed. That has been updated. Now, is that way in Windows Server? It's not that way in Windows 10. So I'm going to go ahead and I'm going to start a virtual machine, and we'll take a look at this in just a moment and see is that still effective or not? Is that still correct? But understand this control panel. Look at this control panel. That looks the same as Control Panel has been for many years. Now maybe the icons have changed a little bit, but the options are all familiar. We've seen these time and time again. So understand that each category has a top-level link like network and internet, hardware, programs, clock language and region. We could select that and then drill into the specific options that we're looking for. Or there are some quick access that we could. If we simply want to uninstall a program, we don't have to click programs and this and that and then finally get to uninstall. We can just click uninstall program. We can also do that by typing. If I type in uninstall, right there, add remove programs. Or here's a quick link to Control Panel. Much easier ways to do things than we had in previous versions of Windows. Let's take a look over in Hyper-V and see if our desktop operating system has started up, our Windows server rather. I'm going to go ahead and connect to it, and I'm going to log in. So let's go ahead. There's Server Manager. That's what we were talking about. If I right-click on the Start button, let's take a look. Do I see Control Panel? No. Understand that subsequent updates since the writing of this textbook have changed that. Okay? Just wanted to illustrate that to each and every one of you. We can configure our system settings and control panel, understand how to do it both in category and classic view. So if we take a look at that, and remember, I'm going to use control panel on my desktop operating system because it's very familiar and it's very similar to what we would see in our Windows Server. So here you can change from category, and I can go to large icons and switch to classic mode, or I could do small icons. Same option, just larger icons and larger text. Or I'm more comfortable working with categories. I think it's just easier. If I'm looking for something specific, I'll just type it in the control panel and I'll do something like update, and I can be able to find system and security. These are all those things that might match that. We can right click our computer and choose properties. We can right click the start button and choose system. All different ways to get to different types of access. So if we want to join a computer to a domain, system is maybe the easiest way to do that. A right click, a left click, and I can go in here and I can rename this PC. There's many other things that I can do. I could join this to a domain from in here. I could get to it. There's different settings in different places. This is the control panel in our Windows Server. So let's jump back over in there. So here's that control panel. How much different is that from my control panel? Here's the control panel in Windows Server, and here's the control panel on my Windows desktop. It doesn't look very different. There's a few different options, but very familiar. You can take many of these instructions in this lesson 1 and apply them to your Windows desktop. We can change our computer name. By out of the box, you're going to see a name simply like Win-DI4JGV, whatever. It's just just a simple string. That's all that's assigned to that computer name. We need to make them more familiar. We may designate our names by the room or the building they're in, or the role that they play, or perhaps something that indicates the type of machine they are, indicating that it's a specific type of a model, and then a sequential number like -01, -02, and so on and so forth. A naming convention. Keep in mind that when you come up with one of those naming conventions for your desktop computers, keep it uniform. Don't start with one type of naming convention and switch to a different. Keep it uniform. Keep it common. We can we can join to our domain. We can change our computer name through our system properties. So remember that each computer must have a unique name. It's critically important. You can't, if you give two computers the same name, you're gonna have problems with their communication. It would be similar to having two people with the same name in your home, and you yell for them, and both of them go, "Yeah, what?" Well, they didn't know who you were referring to. Communication issues. We can walk through some of the settings on how we add a computer to the domain, what the remote desktop protocol is, RDP. And remember, there's a lot of these TCP and UDP ports that you learned in our first sections of our networking support services, such as port 80 and port 443, which is HTTP and HTTPS. And then there's also port 20 and port 21 and port 22. What about port 25 for email? What about port 53 for DNS? Well, RDP was designed by Microsoft. It was developed by Microsoft. It uses TCP port 3389. I guarantee at some point you will see a test question that wants to know something about that. Remember, 3389 is Remote Desktop Protocol, RDP. By default, all system administrators, all domain administrators have the rights to remote to a domain computer. If a computer's been joined to your domain and you are the domain administrator, you have the rights to remote into that. Now there can be options of don't allow remote connections to this computer. If allow remote connections to this computer is selected, out of the box, domain administrator has that access. There we can set up remote assistance. We can change date and time. We're going to become very, very familiar with Server Manager. As I indicated in your setup video, Server Manager is where we're going to perform almost all of our tasks. We can add, remove, and modify server roles and features. We can perform our server management tasks, not just local server management tasks. We can also do server tasks on other servers. Let's take a look at that jump box that I was talking about. This is a Windows 8 machine running Server Manager. You don't have to only have Server Manager on a server. You can install it on your Windows desktop. So as you can see, I've got many different servers that I can manage from this one interface. I can go into DHCP or DNS or Group Policy Management or Hyper-V Manager or Print Manager, Active Directory users or computers, system configuration, routing and remote, all the options that are available on these servers are available to me through Server Manager. That's the power of being able to remotely manage servers without ever having to actually connect to them. If I want to see all servers, here are all those servers. The different individual servers for individual roles. We're going to see more of this as time goes on. And how to access Server Manager. It loads up automatically when we start our Windows server. Now we can also run what's called an MMC, a Microsoft Management Console. This gives us the ability to view many of those administrative controls. For example, if I do a flag R to run, that's that little Windows flag down by your spacebar and the R key held simultaneously, flag R. And I type in MMC. It asks me, yes I do. Here is a Microsoft Management Console. There's nothing there. You go to File, you go to Add, Remove Snap-ins, and here are all the administrative tools that I can access. For example, if I want to see what certificates are installed on this computer, and we'll do this many times over, we can select, for example, the computer account, say Next, and yes, I want to do see, I can view for another computer if I'm on a domain. But we're going to do our local computer. We click OK, and now we can see the certificates that are installed onto this system. You say, well, that's not what I wanted. I wanted something else. I can go File, Add, Remove, Snap-in, and I can add additional things. Let's say I want to be able to see Device Manager. I want to be able to see, for example, let's pick something else. Local users and groups for the local computer. If we were on, if we needed to add a local user to another computer on our domain, we could do it this way. We click OK, and now there are all those additional options. We can customize a Microsoft Management Console for what we want to see at one touch. For now, we're just going to go ahead and close it. But you can, here are a listing of all those different types of options that you have access to. So what I do want you to understand is when we go to Server Manager, for example, if we come back over here and we go to Server Manager and we click on a tool and we open up one of these options, for example, DNS. This is a Microsoft Management Console. It's a pre-built one. These are the ways that we manage our services through that MMC. You can create a custom one. We just saw how we do that, right? Using that, we could add a user account. Or we could simply go to Computer Management, go to Local Users and Groups, click Groups, double-click Administrators, click Add. What are they talking about? They're talking about this right here. If you go to Computer Management, this is that same Computer Management, and you'd be able to add a local, well, wait a minute, where's Local Users and Groups? It says it right there, Local Users and Groups. Well, this is a domain controller. There is no local users and groups in a domain controller because you're on a domain. Member servers, desktop computers, they would all have the local users and groups. If we're going into networking, we're using the same protocols to do our networking as your desktop computers, as our switches. We're using IP, we're using TCP, the TCP IP suite. We can use both IPv4 and IPv6. By far and away, we're much more familiar with IPv4. It's a little bit easier to remember those numbers. We're going to take a little bit deeper look into IPv4 and IPv6 and get a little bit deeper understanding. We have worked with IPv4 and IPv6 in our A+ and Network Plus content. So now we're going to revisit it. We're going to start reinforcing all this knowledge that we've had. You know, the internet as we know it today, a lot of it came about because of our government and because of what was called ARPA, the Advanced Research Projects Agency that the Defense Department funded. That eventually became DARPA, and ARPA created ARPANET. And it was originally built to be able to provide a way for the government to communicate. This is where they first developed the Network Control Protocol. That was the predecessor to TCP/IP. Eventually, we ran out of IP addresses that IPv4 can support, and now we have to rely on IPv6. For our internal networks, we can still use IPv4 because remember that's a private address space, cannot be routable on the internet. We're going to review our IPv4. Make sure you understand how to convert from binary to decimal, from decimal to hexadecimal, from hexadecimal to binary. And remember what you learned in Network Plus about a host ID and a network ID. We're going to be using Class B and Class C addresses in these exercises. If we use a Class B address, you can see it there on your screen in Table 1-2. Class B address 255.255.0.0 is our subnet mask. That means all the bits are turned on in the first two octets. All the bits are turned off in the last two octets. Our network ID is at 255.255.0.0. That's the network portion. All where the bits are turned on is the network portion. Where the bits are turned off is the host portion. We need to revisit, make sure we understand the classless interdomain routing, CIDR. It gives us the ability to build flexible sized networks. A Class C network can have its most 254 IP addresses assigned. But what if I need 1800 IPs? Do I need to build 4 different networks? No, I can use classless routing to create a network that is the size that I need it to be. We're going to take a little bit better understanding of what IPv6 is and the fact that we can have multiple IPv6 addresses assigned to a single system. We still have unicast and multicast addressing, but the unicast addressing can be divided into 3 different types of addresses. We need to make sure we understand what our default gateway is. And that's our way to get from our local network to other networks, be it the internet or to other subnets in our network, in our greater network. What is name resolution? Name resolution is the ability to take an IP address and associate it with a name that's easy for the human element to remember. We all know Google.com. But do you know the IP address that's the actual address of the servers that host Google.com? No, I certainly don't. That's what the DNS domain name system does. It resolves what is the name resolution of a host name to an IP address. When we type in a browser, and for example, to get to our textbook, we go to vitalsource.com. We don't worry about what the IP address of that server is. We let DNS do that work for us. It's a hierarchical system. We have our root, which is a dot, and that's followed by our top level domains. The .com, the .net, the .edu, the .gov, the .org, the .biz, whatever it may be. And then our second level of a Microsoft or a Bing or a Google or an Amazon. We can have additional subdomains within that. For example, our test environment is a datum.com. Well, we could create an additional domain that was sales.adatum.com or research.adatum.com, each getting assigned to different name servers and different administrative support. Be aware that each one of these names can be up to 63 characters in length, but the entire domain name may not exceed 253 characters. Now, for us, those root domains are managed by ICANN. That's the Internet Corporation for Assigned Names and Numbers. And it's done under the authority of the United States Department of Commerce. Just as we just discussed, those top level domains, that's your .coms, your .edu, your .gov. The second level domain is what we think of as being a typical domain name, a typical website name of our Microsoft.com. And then our second level domain can have subdomains. Sales.contoso.com, research.contoso.com. When we append a host name in front of that, for example, here is our server. Our domain controller for adatum.com is lun-dc1. Well, if our name is, if we create lun-dc1.adatum.com, that is what we call a fully qualified domain name. And for example, that is how the host or the server would be identified in the domain. The example of computer1.sales.contoso.com, that is the same as the computer1 in the sales subdomain of the contoso.com domain. Computer1.sales.contoso.com is a fully qualified domain name, FQDN. Now, in our DNS, we have many resource records. We can have every zone. We can have forward-looking zones, which host our domains. We can have reverse lookup zones to be able to not only take a host name to an IP address, but be able to resolve that IP address to a host name. Every zone we create by default has an SOA and an NS record. That's start of authority and name server. Those are there by default in every zone. Every host that gets created in one of those zones has an A record, or every record that is associated with an IPv6 address is a quad A record, an AAAA record. In those reverse lookup zones, pointer PTR records associate an IP address to the host name. So remember, an A record associates a host name to an IPv4 address, while the pointer PTR record associates an IP address to a host name. That's the reverse lookup. MX records, mail exchange records, identify where do we find the email servers in a domain. We'll take a much deeper look into DNS as our course progresses. But be aware, in that DNS hierarchy, understanding how our name resolution works, there's two components to resolve names to IP addresses. We can have a resolver and a name server. A resolver is an application that provides address information about other network hosts for the client. If a client can't resolve a destination's host name to an IP address, the resolver sends a query to DNS servers to look up the record. The name server is a server that performs what's called recursive and iterative queries to contact other DNS servers in an attempt to resolve a host name to an IP address if it doesn't know. So my host computer wants to go to a website. If I've already been to that website before, I've cached that name record and I can immediately go to the website. If I don't know, I need to contact my DNS server, and that's what the resolver does, to find out, hey, what is the associated A record for me to get from this name to this IP address? If my name server doesn't know, it can query other domain name servers, and then in turn it will have a copy of that record that it caches, and I will have a copy of that record that I cache. Now, configuring IP settings and name resolution settings, this is done the same as in Windows Desktop. Whether we're working in Windows Server or Windows Desktop, we use the same setup, same utility to do it. And in your setup instructions for 70-740, we went through this, setting the static IP addresses and changing the computer names and joining it to our domain. So this is now reinforcing that knowledge. Moving on, we can set specific settings if we want. We could go in and change specific IP settings, DNS settings, WIN settings through the advanced settings. We can change the order that our DNS server addresses are contacted. We can append primary and connection specific DNS suffixes. We can define static IP addresses. We'll be doing this in our exercise. We'll be looking at how that's done. When we use DHCP, we're using automatic IP address assignment. Remember DORA: discovery, offer, response, acknowledge. First off, a DHCP client broadcasts a message. Hey, are there any DHCP servers out there that can offer me an address? Well, the DHCP server over here says, hey, I've got an address I can offer you. So the first is discovery, the second is an offer. And the client says, yes, I will accept that. Also, over here is a second DHCP server. You'll notice these are the same addresses. Addresses accepted. Well, this offered 10.182. This one offered 10.25. We responded to both saying we've accepted 10.25. This one goes, okay, we won't worry about you anymore. And over here is where our address gets assigned from. We get lease periods. We looked at this very briefly as we set up DHCP. But remember DORA. Remember Dora the Explorer from being a little kid? DORA: discover, offer, request, and acknowledge. Moving on, understand that there can be stateful and stateless DHCP, and understand how those work. Make sure you read through this. What is Windows PowerShell? PowerShell is a powerful scripting interface for us. It used to be all we had was command prompt. No more. We can now access PowerShell. And here is PowerShell, and let's make that a little bit smaller. Don't need to take up the whole screen. This is Windows PowerShell. And for example, I could type in get dash computer and I can hit tab to do a tab complete. And if I press enter, it's going to gather the same information that's presented to me through computer information. If I do a graphical search, all that same information is displayed here. And then I could turn around and I could pull out particular types of that information. If I wasn't sure how I wanted to use that, I could use the get-help for get computer info. And I could say detailed. And here is help available for how I'm going to run that command. Many different things that you can do. Remember, command prompt allows you to run a command. PowerShell allows us to run scripts and create scripts. For example, I used the get-computer info. If I want to create something, I could use add or new. If I wanted to make a setting, I could use set. If we wanted to delete something, we could use remove. Many, many, many options for using PowerShell. Very, very powerful. And for example, if we want to see the processes just the same way as in Linux, if we want to see what the running processes are, we can do PS. Here are all those running processes on this system. The same thing you might see from Task Manager. There's the PID, the process ID, handles, all that information, all available without having to right click, go to Task Manager, go to much quicker. So in this lesson, we talked about what the desktop is and what we see, and the fact that Windows Server 2016 settings give us a modern interface for those common configuration items that always used to be in command and control panel. How the benefits of Server Manager can be leveraged to be able to manage not only our server, but other servers. and the fact that it doesn't have to necessarily be done from a server. We illustrated the use of a Windows 8 desktop running Server Manager to be able to manage servers. The fact that we use DNS and host names, and we need to be able to resolve those host names to IP addresses. How we can use IPv6 to be able to give us greater number of IP addressing because our IPv addresses simply don't exist anymore, with the caveat that we use IPv4 all we want in a private setting. And finally, we took a brief look at Windows PowerShell. We'll be using Windows PowerShell on a regular basis, so we'll become more and more familiar with that. I hope you enjoyed Lesson 1 in 70-740. Thank you.